In problem 3, we looked at a box sitting on a slope with friction. In that situation, we imagined that this was sliding down. But now let's consider the scenario where there is enough static friction that this box is stationary. Now, at some point, if you keep increasing this angle, there's going to be so much gravity force along the x direction that the box will begin to slide. Static friction can't hold it in place forever. So we're going to solve for that critical angle at which this box begins to move. So let's say that there is some coefficient of static friction, mu s, that's holding this box stuck to the slope. If we do our Newton's second law analysis, we just did it in problem 3, you got this result that A equals g sine theta minus mu cos theta. That was true when mu was for kinetic friction. In the static case, static means things aren't moving. The acceleration is 0. Now, we've replaced mu with mu s for static. And what this equation is really saying is that there is enough static friction to hold this box in place against the force of gravity that's trying to move it up to some maximum situation. Because at some point, this just gets too steep, gravity becomes too strong, and this guy can't hold the box there. Turns out that this equation we've written is that condition to find the maximum value of mu, of that static friction. So we can solve this equation for theta and express theta in terms of mu and find this relationship for the maximum angle that you can hold the slope at before the box starts to move. So let's do this. We'll write an equation for theta in terms of mu. First thing you might notice is that you can divide both sides by g. Now we can do some more algebra. Sine theta equals mu cosine theta. Sine theta divided by cos theta equals mu. Sine over cosine is tangent. And now we have this relationship between angle and coefficient of static friction. So if we are given the coefficient of static friction and we want to find that maximum angle, we can just do inverse tangent and that's the biggest angle you can have before the box starts to move. So in the problem I gave you, we said that mu s was 0.3. Which gives you a maximum possible angle of 16.7 degrees.